Welcome to part 2 of simplifying algebraic expressions. In this video, we're going to take a look at how to use both of these activities in combination to simplify expressions. Remember, in the first part of this video, we learned how to combine like terms, even with using the dreaded fractions. In this video, we are going to learn how to use that in concert with the distribution property, and then we will simplify our expressions. Now, your book tends to make a little bit of hay about the activity of distribution. Really, it's nothing more difficult than distributing like we showed you in the previous video, where we take a number. In this case, we have negative of the quantity a minus b, and there's a couple of different ways I'd like for you to read that. One, the most important way would be to say the opposite of the quantity a minus or subtract b. So this is the opposite of the quantity a minus b. That way we can look at it in a few different ways as far as the distribution goes. In the first way, we can just say, well, if it's the opposite of a minus b, wouldn't the opposite of that be, in fact, b minus a? And that would be correct. That's one way to look at it. The opposite of the quantity a subtract b is b subtract a. That's absolutely true, but let's look at why that's true by taking a look at the opposite of a minus b. Remember that any quantity is multiplied by a 1, and in fact, in this case, because we have the opposite of that 1, it's basically a negative 1 times the quantity a minus b. The object of multiplying any number by a negative 1 is simply to change the sign of that number. So a times a negative 1 is a negative a, b times a negative 1, a negative b times a negative 1 is a positive b, because a positive times a negative is a negative, and a negative times a negative is a positive, as we've seen in previous videos. So this time when I go to distribute my negative 1 to the a term and to the negative b term, what happens is a negative times a positive gives me a negative a, and a negative times a negative gives me that positive b. So basically what I have is the opposite of a minus b is a negative a plus b. And by the commutative property, we can just as easily turn that around to say b minus a. Okay, let's up the stakes just a little bit. Let's take a look at an expression that says 6 minus 3x plus 8. That's 3x plus 8 is a quantity, so we'll read that as 6 minus the quantity 3x plus 8, or 6 subtract the quantity 3x plus 8. Now remember, because we have the subtraction symbol in here, and even if we didn't have the subtraction symbol in here, we do still have 1 times that quantity. We have one quantity of 3x plus 8. So what we'll do is we will distribute that negative 1 to the 3x and to the 8. And so what it looks like is this 6 does not get distributed. So we're just going to bring that straight down. And now we take a negative number times a positive. So this is how I like to do it. I like to multiply the signs first and then the numbers. A negative times a positive is a negative, and a 1 times a 3x is just 3x. See, the signs first and then the numbers. A negative times a positive is a negative. 1 times 8 is 8. So we've done the distribution part of our problem. Now let's try the combine like terms part. This negative 3x doesn't have a partner to play with. There are no like terms, but I do have a constant term here, 6, and a constant term here, negative 8. Notice that the sign is the same thing as the operator. The operator minus is the same thing as the number negative 8. Basically, negative 8 or minus 8 means the same thing as plus a negative 8. You'll remember from another video. So basically what we have is this negative 3x here, which is going to be left alone, and then this 6 minus 8. So if I have $6 but I owe somebody $8, after I pay them off, I still owe them $2. And we are simplified there. No more like terms, no more combining. One more example. Okay, here we're going to have a little fun. we've got 7x plus 3 times the quantity 2x minus 4 minus 2 times the quantity negative 8x minus 10. So let's take a look first at what it is we're going to distribute. We are going to distribute this 3, this positive 3, and it's going to get distributed to my 2x there and to my negative 4 there. Then we will also distribute this negative 2. The negative 2 is going to get distributed to the negative 8x, or the opposite of 8x, and the opposite of 10. The 7, not being multiplied by any quantity, it's just 7x, that's just going to stay what it is. So we have 7x's, and then what is that going to be combined with? Let's take a look at the first part. It says a positive times a positive is a plus 3 times 2x is 6x's, and then we have a positive times a negative now is a negative 3 times 4 is 12. And with our next term that we're going to distribute, this negative 2 here, we have a negative times a negative, which is a positive. 2 times 8x is 16x's, and a negative times a negative is positive again, and 2 times 10 is 20. So I have a bunch of like terms. Let's use the commutative property so that we can move things around. What I really have is 7x, then I have another plus 6x here, and then I have another plus 16x there. All right, that's cool. And then we will have, let's do our constant terms. In this color, I have a negative 12 there, minus 12, and then a positive 20 there. You don't have to rearrange these. It just makes it visually more accessible if you do. So again, if I have 7 of something plus 6 of something, that's 13, plus another 16. I believe that's 29 of that one thing. And then if I owe somebody $12, but I have $20 once I pay them, I still have positive $8, and it looks like that is fully simplified.